Hi, welcome back. We're going to continue our study of properties of functions with a quick recap about injectivity and surjectivity. Remember, a function is injective if every element in the codomain is the image of at most one element in the domain. In an earlier video, this was considered having no collisions. Some other language that you might hear in other places when you talk about injective functions are one-to-one functions and injections. It is important to realize that when you see one-to-one function, that's not the same thing as a one-to-one correspondence, as we'll talk about later. In the second video, we saw that a function is surjective if every element in the codomain is the image of at least one element in the domain. I like to think of this as saying that everything is hit. Everything in the codomain has at least one arrow pointing towards it. Other words that are associated to surjective functions are onto functions or surjections. In this video, we're going to talk about what happens if something is both injective and surjective at the same time. That is, every element in the codomain is the image of at most one element in the domain and at least one element in the domain. In other words, every element in the codomain is the image of exactly one element in the domain. We call this a bijective function. A function is bijective if it is both injective and surjective. One interpretation of this concept is that f pairs up the elements of x and y. If we look at this example, every element in the domain is paired up with some element in the codomain. This is the idea of a one-to-one correspondence. Every one element in x is paired up with one element in y. And another name for a bijective function is a bijection. Let's look at some examples. First, let's consider this function from the set 0, 1, 2, 3, 4 to the set 0, 1, 2, 3, 4 defined by f of x is equal to 4 minus x. 0 goes to 4, 1 goes to 3, 2 goes to 2, 3 goes to 1, and 4 goes to 0. You can see this is pairing up elements in the domain and elements in the codomain. Here's another example. Here's a function m between the elements from 1 up to 12 and the months of the year, where we define m of a number to be the nth month of the year. There are 12 numbers from 1 to 12 and 12 months in the year, and we're connecting them in the natural way. Each month corresponds to one number, and each number corresponds to 1 month. So this is a bijection between these two sets. Now let's look at what can go wrong. Here are some non-examples. Consider the function g from the numbers 1, 2, 3, 4, 5 to the letters x, y, z. 1 goes to x, 2 goes to y, 3 goes to z, 4 goes to z, 5 goes to y. We see that both 3 and 4 have z as their image, and therefore this function is not injective, which means this function is not bijective. Let's look at another example, the birthday function we saw in a previous video, where b is the function that takes the set of Queens College students into the set of days of the year, where b of a student is the student's birthday. Now there are well over 365 different students at Queens College, and therefore at least 2 of them have to have the same birthday. That means, again, this function is not injective, so it's not bijective either. Do notice that we don't know whether the birthday function is surjective or not. With thousands of students, there is probably a birthday every single day of the year, but that's not guaranteed. One thing that you're noticing is that in order for a function to be bijective, the domain and the codomain have to have the same cardinalities. A bijection pairs up the elements in x and the elements in y. So if x and y have different cardinalities, a bijection between them is impossible. That's it for now. See you next time.